You spent 3 months building a model with 94% accuracy. You were proud of it. You presented it to the business team. They asked one question: what does 94% accuracy actually mean for our customers? You did not have a clean answer. The model never shipped. That moment happens to almost every machine learning engineer, sometimes early, sometimes later than it should. And it reveals the biggest truth in this entire career. Being technically correct is not the same as being useful. No university course teaches that properly. No Kaggle leaderboard rewards it. But the entire ML career is built around learning it. That journey has levels, real responsibilities, real pressure, real money, real mistakes, and real moments that decide whether you grow or plateau. This is what the journey actually looks like. Level 1, ML Intern / Trainee ML Engineer. Your first task is not building a model. It is reading documentation for a pipeline someone else built 18 months ago. The documentation is incomplete. 2 libraries are deprecated. 1 environment variable no longer exists. Welcome to machine learning engineering. You spend your first week setting up your environment. CUDA conflicts, CUDNN mismatch, Python version issues, Conda environments refusing to resolve, a requirements file that works on one machine and breaks on another. You search error messages late at night. You find a forum thread from 2019. The accepted answer says, fixed in next version. The next version created a different problem, and this is your first surprise. These are not beginner problems. Senior engineers fight the same battles. They just panic less. Then the real project arrives. A dataset with millions of rows. You're asked to identify churn risk. You open the file. Missing values, broken dates, duplicate rows, outliers, 17 spellings of the same category. You expected modeling. Instead, you clean data for weeks, and that becomes your first real lesson. The model is only part of the work. The data is everything underneath it. You train your first serious model. It performs well. You are excited. Your mentor asks, "What is the baseline?" You freeze. Then you compare it to a simple, naive approach. Your complex model barely wins. That hurts, but it teaches something important. Good ML engineers do not ask only, "How good is my model?" They ask, "Is this improvement worth the cost?" You finish the internship. You may not ship anything users ever notice, but you learn more from real messy systems than years of clean classroom datasets. That is why internships matter. Level 2. Junior ML Engineer. Now you are full-time. Your title says Junior ML Engineer. Your real job is simpler. Maintain systems seniors designed. Improve them carefully. And do not break production. At this level, brilliance is optional. Reliability is not. You learn the real stack, not just Sklern or PyTorch. Feature stores, experiment tracking, training pipelines, model registries, serving infrastructure, monitoring dashboards, CI/CD, data versioning. This is when many people realize training a model is one task. Shipping one is an entire system. Then your first production issue happens. A model slowly gets worse over time. Nothing crashes. No alarms fire. Metrics just decline quietly, week by week. The cause? Distribution shift. Real-world data changed. The training data did not. And now you learn another truth. A model is not finished when it ships. Shipping is when the real work begins. Then comes the classic junior mistake. A stakeholder asks for ticket priority prediction. You build an advanced NLP pipeline, embeddings, fine-tuning, complex pre-processing. A senior asks, "Did you try logistic regression first?" You had not. You test it. It gets almost the same results, runs faster, costs less, ships immediately. Your complex system never goes live, and that lesson stays with you. Simple solutions win more often than people admit. Your first review arrives strong technically, needs better communication. You think, "I'm an engineer, not a presenter." That mindset will not survive the next level. Level 3. Machine learning engineer. Around year 2 or 3. Something changes. You stop asking, "How do I build this?" and start asking, "Should this even be built?" That question changes careers. You own a project end-to-end, a recommendation system, a forecasting engine, a fraud model. Whatever it is, you now understand something critical. The model should come after the problem definition, so you ask better questions. What metric matters? Revenue, retention, user trust, latency, false positives. These goals often conflict. Now you have opinions. Strong ones. When to use a model, when not to. When a rules engine is enough. When a lookup table beats AI. A product team asks for an upgrade prediction model. You inspect the data. Most users upgrade after crossing one usage threshold. One clear rule predicts behavior better than a complicated model. You implement the rule. It works. Someone asks, but where is the AI? You answer calmly, the best solution is the one that solves the problem, not the one that sounds impressive. Then the LLM wave hits. Everyone wants AI features, chatbots, summaries, assistants, search, automation. You lead implementation and quickly discover reality, hallucinations, latency, token cost, prompt instability, evaluation chaos. There is no neat accuracy score, no clean benchmark. You build testing frameworks before features, because shipping LLM products without evaluation is not innovation, it is risk. You also become more valuable in meetings, because now you can translate technical ambition into cost, reliability, and business trade-offs. That skill compounds. Level 4 is Senior ML Engineer. The promotion arrives, Senior ML Engineer. The title feels good for about 1 day, because now the problems become ambiguous. Nobody gives you clear tickets anymore. They say, retention is falling. Can ML help? Fraud is rising. Can ML help? Customers are leaving. Can ML help? Your first task is no longer coding. It is defining the real problem. You analyze data, talk to product, read support logs, study user behavior. Sometimes the answer is a model. Sometimes it is pricing. Sometimes onboarding. Sometimes poor UX. This is what separates senior engineers. They solve the actual problem, not the requested one. Then comes a painful lesson. You recommend a sophisticated deep learning ranking model. The design is smart. The code is strong, but the company lacks enough quality data. In production, a simpler baseline performs better. 2 months lost. You do not hide. You write the postmortem. Then build a framework for future model selection, available data volume, latency limits, interpretability needs, maintenance cost, business value. That framework helps the company for years. This is senior behavior, turning mistakes into systems. Then a stakeholder demands launch in 6 weeks. You know it needs 12, not for training, for monitoring, rollback plans, /B testing, safety checks, documentation. You say no, respectfully, clearly, with reasons. The room gets quiet. Then leadership agrees. And this is another truth. Communication is not a soft skill. At senior level, it is core engineering leverage. You also start mentoring juniors. You realize helping others improve can outperform your own individual output. That realization prepares you for the next level. Level 5, Staff or Lead ML Engineer. Now your scope changes. You're not focused on one team. You move across teams. You notice patterns others cannot see. 3 teams are building separate feature pipelines for the same data. 3 versions, 3 costs, 3 future disasters. You propose one shared platform, not casually, with architecture, migration plan, risk analysis, ROI. Leadership approves it. You coordinate multiple teams, resolve disagreements, set standards, unblock progress. You write less code than before, but your impact becomes far larger. That is the shift many engineers struggle with. At senior level, output matters. At staff level, leverage matters. You define better engineering standards, model documentation, evaluation requirements, incident response playbooks, pipeline review practices. Now dozens of engineers make better decisions without asking you first. That is scale. You also mentor strong senior engineers trying to level up. Most make one mistake. They optimize for personal output, but staff engineers optimize for organizational velocity. That is a different game entirely. Level 6, Principal, or Head of ML, or ML Architect. Very few engineers reach here. At this level, you do not just build systems. You shape direction. You advise leadership on where ML should matter and where it should not. The CEO asks about the AI roadmap. You do not talk about models. You talk about capabilities, hiring, infrastructure, risk, return on investment, timelines, data readiness, because top-level ML work is not model obsession. It is clear thinking under uncertainty. A company wants a bold AI initiative. You assess it honestly. The model is possible. The organization is not ready. Bad data pipelines, weak labeling process, no deployment maturity, no monitoring culture. You explain. This is an 18-month foundation problem, not a 3-month model problem. That honesty saves millions. This is what experience eventually becomes, not knowing every algorithm, knowing what actually matters. Somewhere right now, someone just trained their first neural network. They hit high accuracy. They feel excited. They think this career is about models. It is not. Models are the entry point. The real career is about asking better questions, choosing simpler solutions, building things that survive production, explaining complexity clearly, knowing when data is lying, knowing when metrics mislead, knowing when hype is noise, and knowing when to start over. The ML engineer who creates real value is rarely the one with the fanciest model. It is the one who understood the problem best, who got the solution shipped, who monitored it honestly, who improved it continuously, and who stayed humble enough to change direction when needed. The titles change, the salary changes, the scope changes, but the core work stays the same. Understand the problem. Build the simplest thing that truly solves it. Ship carefully. Measure honestly. Improve continuously. Never stop learning. That is the career. From the first CUDA error to the boardroom AI strategy. And you are somewhere on that path right now. Comment below what level you think you are at. And if you are still at the beginning, good. That is where everything starts.